Welcome back. This is 3.3, the point-slope form of the equation of a line, scatter plots, and regression lines. So we're using point-slope form to write equations of a line, write linear equations that model data and make predictions, make a scatter plot for a table and data items, and interpret information given in a scatter plot. Point-slope form of an equation is the point-slope form of the equation of a non-vertical line with slope m that passes through the point x1, y1. So this is your point-slope formula. So writing the point-slope form and slope-intercept form. So write the point-slope form and then the slope-intercept form of the equation of the line with slope 2 that passes through the point -1, 3. So we're just going to be replacing what we know. So m, x1, y1. So y minus 3 equals, oh, we know what m is, it's 2. X minus a -1. So it'd be y minus 3 equals times x plus 1. All right, and then this is the equation of the line in point-slope form. And then now we want it in slope-intercept form. So we have y minus 3 equals 2 times x plus 2. So I just distributed that 2. All right, now we're going to add 3 to both sides. So we get y equals 2x plus 5. So those are the two different ways you can write that equation. All right, writing the point-slope form and the slope-intercept form. So a line passes through the points 4, -3 and -2, 6. Find the equation of the line. So we want to find the slope. So you can do it by doing your rise over run. So it's going to go down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. So down 3 over 2. You can also do the slope formula if you don't remember your rise over your run. Oh, that's an x. So equals y1, x2, y. So it'd be 6 minus a -3 over -2 minus 4. So 6 plus 3 over -2 minus 4 is -6. So it'd be 9 over -6, which is -3/2. So that same thing. All right. The slope form equals m x minus. So y minus a -3 equals our slope times x minus 4. So it'd be y plus 3 equals -3/2 x minus 4. All right, slope-intercept form, that means we distribute and move. So it'd be y plus 3 equals -3/2 x Then we want to do negative 3/2 times the negative 4. So we get positive 6. That's because that 2 can cancel from 4. So plus 6. And then negative times a negative makes a positive. All right, then we'll subtract 3. So we get y equals negative 3 over 2x plus 3. You can also notice from the graph, your y-intercept is at 0, 3. So remember, that's your intercept there. So you can get it from the graph or by looking at your equation. All right, equations of lines. So we have standard form, y-intercept form, x-intercept form, slope-intercept form, point-slope form. That should be x equals a. I don't know why it has y. All right. Modeling the graying of America. So we're going to model using what we know. So it says, write the slope form of the equation of the line shown below. Use the function to predict the median age of the U.S. population in 2020. All right, so first we want to find the slope. So we have our 2 points. Oh, I want to circle that one twice. So x1, y1, x2, y2. So that's written on this next slide. So x1, y1, x2, y2. So 35.3 minus 30 over 30 minus 10. So 35.3 minus 30 is going to be 5.3 over 20. Or we can do it in our calculators. So 35.3 minus 30 divided by 30 minus 10. And if we turned it back, well, it won't go back into a fraction nicely because it's that 5.3. So if you do 5.3 over 20, I messed up and did it as 10. So it's 5.3 over 20, we get that 0.265. All right, so then we put it in our slope-intercept equation, but this is our point slope. So we want to get it in that the y equals mx plus b formula. So y minus 30 equals 0.265x. And then we want to multiply that by 10. So 0.265 times 10, it just basically will move the decimal place over. So 2.65. All right, then we want to b. So we get y equals 0.265x plus 28.65. Because that was a negative. Oh, it's 27. Oop. There we go. 27.35. Oh gosh. There we go. That works. Okay, so now, my brain was having a moment. So now we want to plug in our years past 1970. So we're calculating 2020 minus 1970. So that gives us the 50 years. So I started writing the other equation on here. So equals 0.265 times 50 minus 20 plus 0.35. So we have 0.265 times 50 plus 27.35. All right, we get 40.6 will be the average age, median age at 2020. All right, scatter plots. So a scatter plot is a collection of data points. One data point per person or object can be used to determine whether two quantities are related. And then correlation is a clear relationship between two quantities and is used to determine if there is a relationship between two variables, and if so, the strength and direction of the relationship. So this is a scatter plot, and it shows a downward trend. So see how the points are going down, with some exceptions. Like there's some that kind of go back and forth. So it says people with increased education tend to have a lower test score on the test measuring prejudice. All right, correlation and causal connections. So the correlation could be simply a coincidence. Education usually, did that have a? That's weird, it doesn't really make sense. So it says, although the scatter plot shows a correlation between education and prejudice, we cannot conclude that increased education causes a person's level of prejudice to decrease. So education usually involves classrooms and a variety of different kinds of people. Increased exposure to a diversity in the classroom might be an underlying cause. Education requires people to look at new ideas and see things in different ways. Thus, education causes one to be more tolerant and less prejudiced. All right, regression lines. The regression line is a line that best fits the data points in a scatter plot. The regression line is a line that best fits the data points in a scatter plot. That was a repeat. That should have been not there. All right, correlation coefficients. So correlation coefficient is designated by R and is a measure that is used to describe the strength and direction of a relationship between variables whose data points lie on or near a line. The relationship is positively correlated if they tend to increase or decrease together. Negatively correlated if one variable tends to decrease while the other increases. Perfect positive correlation in which all points lie precisely on the regression line that rises from left to right. And then perfect negative correlation is in which all points in the scatter point lie precisely on the regression line. Oh, I can't talk today. I'm sorry. Regression line that falls from left to right. I should have just had you read the slide. All right. Interpreting a correlation coefficient. Math provides an objective way to look at social and political issues. For example, the points in the scatter plot on the next slide show the number of firearms per 100 persons and the number of deaths per 100,000 persons for the 10 industrial countries with the highest death rates. The correlation coefficient for the data is 0.89. What does the correlation coefficient indicate about the strength and direction of the relationship between firearms per 100 persons and deaths per 100,000 persons? All right, so it's graphed over here. So the correlation coefficient R equals 0.89 is close to 1, indicating a strong but not perfect positive correlation. There is a moderately strong positive relationship between the number of firearms per 100 persons and the number of deaths per 100,000 persons. As the number of firearms per 100 person increases, the number of deaths per 100,000 persons also tends to increase. So if we look here, you can see, like if we did a line here, they kind of fall within that line, and it's a positive correlation between those, that they fall within a little bit of each other. So that's what that means, is that correlation coefficient. It means that they respond to each other in a positive way. All right, that is it for 3.3. So let me know if you have any questions and go ahead and work on your assignment.